And today, as you mentioned, the leading, in fact, only candidate for a theory of everything is string theory. And by the way, the first people to talk about string theory were the Greeks thousands of years ago. Pythagoras, the famous Pythagorean theorem, 2000 years ago, had an idea. He saw a lyre string vibrate, and he said to himself, well, that creates music, music of vibrating strings, harmonics, notes coming from a vibrating string. And then he said to himself, maybe the universe is nothing but vibrations on strings, creating music. And that's what we think today the universe is music, the language of vibrating strings. So each vibration corresponds to a subatomic particle, like an electron or neutrino. That would be an electron, that would be a neutrino, for example. And what is physics? Physics is the laws of harmonies of these strings. What is chemistry? Chemistry is the melodies you can play in vibrating strings. What is the universe? The universe is a symphony of vibrating strings. And then what is the mind of God? The mind of God would be cosmic music resonating through hyperspace. That would be the mind of God.
So you mentioned Einstein in your quest to solve his unfinished work. The title of your most recent book, The God Equation, even mentions that, and you just discussed that. In a series of letters that Einstein wrote, he famously wrote, God does not play dice with the universe. That God tirelessly plays dice under laws which he has himself prescribed. Einstein believed there must be some underlying laws which could define nature and their particles. So, how does the God equation resolve the differences between what Einstein pointed out with the smooth, gravity driven, expanding universe and quantum physics, where particles can be in two places at once and dark matter is in the driver's seat?
If any of you in the audience listening to this interview hear the question and know the answer, what should you do? You should first tell me first, and we'll publish together and we'll win the Nobel Prize together, you and me. Well, this quest has to do with whether or not we can create a universe using mathematics. The mathematics of vibrating strings. All of biology can be explained in the language of chemistry. All of chemistry, in turn, can be explained in the language of physics. All of physics, in turn, can be explained in two languages: the language of the very big, that is, relativity of Einstein, black holes, quasars, neutron stars, all the stuff you read about in astronomy books. That's the theory of general relativity of Einstein. Then we have the theory of the very small, that is, the quantum theory, which makes possible lasers, the internet, transistors. This conversation is brought to you compliments of the quantum theory. The problem is, if Mother Nature has a left hand and a right hand, that is, relativity and the quantum theory, why don't they talk to each other? Think about that. These two theories are incompatible. They don't talk to each other. They're based on different mathematics, different assumptions, and Einstein even has second thoughts about the quantum theory. What we need is a unified theory that marries the quantum theory of atoms with Einstein's theory of black holes and Big Bang. That's the theory of everything. So the left hand and the right hand talk to each other, and we have a theory that describes the very small and the very big. That's where string theory comes in. Now, some people say to me, Professor, maybe I don't like string theory. Give me an alternative. Plan B, another theory. Well, sorry, there is none. Many proposals have been made over the last several decades. Every single one of these proposals, except string theory, has been ruled out because they don't fit the data or they are mathematically inconsistent. Now, that doesn't mean string theory is correct. It just means it's the only game in town. And we may have to build bigger machines to finally test the theory once and for all. Already, the Japanese, the Chinese, and the Europeans are making proposals for a successor to the Large Hadron Collider in Geneva, Switzerland, the biggest atom smasher of all time, a replacement which might just be big enough to prove the correctness of string theory, which says that the universe is nothing but music.
Speaking of modern physics and time travel, both, as you've mentioned, require an immense amount of energy. How do you see physics progressing, at least in this century? String theory, all of these things require so much energy that we probably can't obtain due to Moore's law slowing down or just physical limitations. How do you see us overcoming that barrier?
Well, I think in the coming years, we're going to develop new sources of energy, including fusion power. We have a reactor in France, the ITER. It'll be turned on in a few more years, and we hope it'll attain break even, that is, generating more energy than it consumes. And the promise there is that seawater, ordinary seawater, could be the fuel for fusion machines into the future. And the first starships, I think within 100 years, we'll probably build the first set of starships, and some of them might be powered by fusion machines. One possibility is antimatter. At the Large Hadron Collider outside Geneva, Switzerland, we already can make beams of antimatter. However, not enough to drive a starship, but we can dream. We can dream about one day, perhaps antimatter engines or fusion engines will take us to the nearby stars. However, to take us beyond the nearby stars, to take us throughout the galaxy, requires a new scale of energy. And that scale of energy we physicists try to quantify. You see, we physicists try to rank civilizations in outer space. A type 1 civilization is planetary. It controls the weather, controls volcanoes and earthquakes. That civilization is sort of like Buck Rogers or Flash Gordon. Then there's type 2. A type 2 civilization has exhausted the power of a planet and it harnesses the energy of the sun, direct energy from the sun. They build a sphere around the sun to extract all the energy from sunlight. They control stars. This is type 2, similar to what you see in Star Trek. The Federation of Planets in Star Trek would be a typical type 2 civilization. Then there's type 3, galactic. They roam the galactic space lanes. They can play with black holes. They can play with star clusters. For example, Star Wars would be a type 3 civilization. The Borg in Star Trek would be a type 3 civilization. Now, what are we on this scale? Do we play with the weather? Do we extract energy directly from solar flares and the sun? Do we roam across black holes and the Milky Way galaxy? No, we are type 0. We get our energy from dead plants, oil, and coal. But we can dream. We can dream of the day one day we'll use the laws of physics to become type 1, type 2, and type 3. Now, type 3, for the most part, is the most interesting. Type 3 can access the Planck energy, the energy of the Big Bang, the energy of black holes. A type 3 civilization might be able to build gateways through the universe, and these are called wormholes. Wormholes are solutions of Einstein's equation, which allow you, in principle, to go faster than the speed of light. So, a type 3 civilization may have the ability to punch a hole in space, to use the Planck energy to drive a starship that'll go across the galaxy. That is consistent with our understanding of modern physics.
Last year, the Xenon project, it houses the world's most sensitive dark matter detector. They seemed to identify something significant, but it wasn't dark matter, it was something else. And researchers later determined, or at least theorized, that what the something else was not dark matter, it was dark energy. And so when I looked into it, there seems to be a lot of dark matter and dark energy in the universe. Some people even say that maybe alien computers are creating that dark matter because of the immense amount of energy they need for travel. But since you're so good at explaining complex topics, I wanted to ask if you could maybe explain dark matter and dark energy to an average guy like myself to understand why they fit into our universe and why they matter to us.
Dark energy is perhaps the most bizarre form of matter in the universe. First of all, it's invisible. If I held it in my hand, you couldn't see it. Plus, it doesn't interact with atoms. In other words, gravity would push dark matter right through my fingers. right through my fingers until it hit the floor. Then it would continue to go right through the concrete of the floor, through the center of the earth. It would continue to go all the way to China. In China, it would reverse direction and come back to New York City. And then it would oscillate between New York and China as if the earth didn't exist at all. Now, this is incredible, but we think it makes up most of the universe. You see, the Milky Way galaxy spins, but it spins 10 times too fast. By rights, it should fly apart like a broken pinwheel. But hey, we're still here, right? Proof that something is holding the galaxy together when the galaxy normally spins so fast it should fly apart. And that we think is dark matter. Dark matter envelops the galaxy, preventing the galaxy from flying apart. And we even have maps of this invisible matter because light going through this invisible matter is distorted. And by running this distortion through a computer, we can create maps of dark matter. Now, what is dark matter? Well, as I said, if you ever figure out what dark matter is, tell me first, and we'll split the Nobel Prize, you and me. We don't know what dark matter is. And there's something even stranger than that, and that's dark energy. You see, the universe is expanding, but the question is why? Gravity is attractive. Newton would say that no, the universe should compress. It should be squeezed by gravity rather than expanding. Something is pushing the galaxies apart, and that's dark energy. Dark energy, which is actually found in Einstein's equations as the cosmological constant. Where does dark energy come from? We don't know the answer to that either. Now, the leading candidate to explain both is string theory. But string theory is still in its infancy, and it's not yet developed enough to make predictions about dark matter and dark energy. But we're getting there. We hope to make predictions about dark matter and dark energy coming from string theory. But right now, it's a mystery. What is the universe made of? The Greeks asked that question 2,000 years ago. And believe it or not, we're still asking that question even today.
Because when you look at dark matter and dark energy, there's massive compact halo objects or machos, and then there are WIMPs, which are weak interactive massive particles. Is science making a little humor out of it as well? Because I find it pretty interesting that dark matter has WIMPs and machos.
Well, yeah, I mean, sometimes we physicists get so bogged down in our equations that we realize that there are people out there that don't relate to us on any level until we can actually come up with something that makes contact with what they are familiar with. Now, believe it or not, WIMPs is perhaps the leading candidate. We think that the string has higher vibrations. We are the lowest vibration of the string. Electrons, neutrons, protons, nothing but the lowest note on a vibrating string. But the string has higher octaves. The next octave could be dark matter. So, in other words, dark matter, instead of being the strangest thing we've ever seen before, is nothing but a higher octave, a higher note on a vibrating string. And that is the leading theory right now. The photino is one of the higher excitations of the string. It is massive, it's invisible, and it is one of the leading candidates for dark matter. So, what is dark matter? Dark music.
I just think there seems to be something innate in us that actually seems to resonate towards string theory. I didn't know what your perspective on that was.
Well, yes, the Greeks 2,000 years ago, as I mentioned, asked the question, what is the universe made of? And two theories came out of that era. Pythagoras went to a blacksmith shop and he saw swords being made, and you have to bang the sword, and the longer the sword, the lower the note. Same thing with the lyre string. The longer the string, the lower the note. And he said to himself, aha, the mathematics of music. That is the language of the universe. Why do we have so many diverse forms of matter? How come we have clouds and rocks and trees and people, so many diverse things? Well, they're just nothing but different melodies. Because how many melodies are there? How many notes are there? An infinite number. And so he founded a school. The Pythagorean school was based on the idea that music was the underlying theme, principle, paradigm for the entire universe. Some critics of the theory says that the theory is incredible. It talks about hyperspace, dimensions beyond the three dimensions. This is science fiction, they say. String theory is science fiction, they say. But look at it this way. Are there other dimensions? Well, when I was a child, I used to go to the Japanese tea garden in San Francisco. Maybe you've been there. And I used to look at the carp swimming in a shallow pond. And I used to say to myself, what would a carp see if I were a carp, a fish swimming in a shallow pond? I would have eyes to the side of my face. I would say that the universe is two dimensional. I could go forward, backward, left, right, but up doesn't exist. There's no such thing as up, the third dimension. And then I imagined there was a scientist fish swimming among the other fish in the shallow pond. And he would say, bah, humbug. The pond is the universe. There's nothing beyond the pond. The pond is two dimensional. That's it, folks. And then I said to myself, what happens if I go down and grab the scientist, lift him up into the third dimension? What would he see? He would see strange beings moving without fins, a new law of biology, beings breathing without water, a new law of physics and chemistry, new laws opening up, leaving the pond of two dimensions. And then I said to myself, maybe we are the fish. We spend all our life in three dimensions, going forward, backward, left, right, up, down, and laugh and say, bah, humbug, anytime someone talks about a fourth dimension or a fifth dimension. Well, string theory says that we live in an 11-dimensional universe. In more dimensions, there's enough room to put in all the theories of nature, the electromagnetic force, the nuclear force, the gravitational force. There's not enough room in three dimensions to put these equations together. But in hyperspace, higher dimensions, there's enough room to fit in all the dimensions. So here we have a situation where physics and science fiction merge with each other.
That's amazing. Thank you so much.
Well, thank you.